Okay, hello everyone. Let's go ahead and take a look at geometric series. So let's go ahead and define that again. We know that the series is a geometric series if and only if the sequence generator is geometric. Or also we can go ahead and say that if the sequence generator is geometric, then the series will be called a geometric series. So let's go ahead and take a look at a particular geometric sequence here, 2, 6, 18, 54. And we know that the use of n term is going to be 2 times by 3 to the n minus 1. Now let's say, for example, we want to go ahead and find out what s sub 5 is. And that's just, of course, in its sigma notation form, or the summation of k equals 1 to 5 of 2 times by 3 to the k minus 1 power. So, the initial statement in which we can use to go ahead and find a geometric series are these two expressions, these two equations right here. Now notice it's exactly the same thing except for the fact that this is r to the n minus 1 and this is r minus 1. And this one here is 1 minus r to the n divided by 1 minus r. Okay? So what's the difference between the two? Well, there's really going to be no difference except for the fact that we want to go ahead and use this one here if r is greater than 1. And if r is less than 1, we want to use this one here. Now, why is that going to be an important fact? Well, the reason for that is because if r is less than 1, and we use this one here, then the denominator is going to be negative, and you're going to have a lot of negatives in there that will cancel each other out. So you might as well go ahead and use this one here and keep everything positive. There's just less chance of mistake. So notice that for both of these situations, then, all we need to know is u sub 1 and n r. So let's go ahead and take a look at this particular s sub 5. Since we know that u sub 1 is going to be equal to 2, there's going to be 5 terms that are going to be adding up. And in this particular case here, I know that the r is going to be equal to 3, which is of course greater than 1. Therefore, I'm going to use this form of the geometric series. So therefore, if I go ahead and substitute n for 5, u sub 1 for 2, and r for 3, I can evaluate it and I can come up with 242, which is going to be the series, geometric series of the first 5 terms of that particular geometric sequence. Now, of course, if we wanted to go ahead and use these two to go ahead and determine the series of a geometric sequence, we can. Now, of course, also remember that we can also go ahead and just expand if we want to. So notice that we say s sub 5 is going to be equal to the summation from k is equal to 1 to 5 of 2 times by 3 to the k minus 1 power. And then, of course, I have 5 terms added together to come up with 242, which again is going to be consistent with what we have there. I can also go ahead and use some of my properties of sigma notation to come up with exactly the same result. So again, if we know that we're dealing with a sequence which is geometric, and then we're trying to add those terms together, then we're going to be dealing with a geometric series. We can either go ahead and expand the sigma notation, we can use our sigma notation properties, or we can go ahead and use either one of those two initial statements here to find out what that geometric series is. If we know what u sub 1 is and an r, and depending upon whether r is greater than 1 or less than 1, we choose either one of those two to appropriately come out with the geometric series. So go ahead and try some of those problems, and we'll go ahead and take a look at any questions that you might have the next time that we meet in class. So see you next time. Bye-bye.